Okay, so let's talk about skin accessories. It sounds so strange, right? It's like I'm talking about necklaces and scarves and accessories. I am not. Alright, so let's draw the surface of the skin, right, to kind of indicate the lumen. And I'm going to, like, leave 2 open spots here just to accommodate something I'm going to draw. So this is the lumen, or the outside of skin, and this is going to be our epidermis right here. And we know that the epidermis and the dermis are separated by these epidermal ridges and dermal papilla. And again, I'm just leaving space for things I'm going to draw. And we've already established that the epidermis itself stains with like a darkish, pinkish, purplish color, but that there is also a layer of alive cells right here, right? And that is still the epidermis. Okay, let's discuss a sweat gland. And that's what I'm going to draw, a pore. I'm going to draw the pore, which is on the surface of the skin. And this pore is surrounded by simple cuboidal cells. And those cells extend all the way down this pore, which is basically a tube, right? And if we were to draw it here, here are these simple cuboidal cells that surround it. What I'm going to do here is I'm going to use blue to indicate the lumen. And that's why simple cuboidal is a type of epithelial tissue. And epithelial tissue lines open spaces. Now, when I get down into the dermis, the sweat gland starts to twist and turn around. My husband hates it when I coil up the garden hose because I don't really coil it up. And that would be that situation right there. But the lumen of sweat extends all the way down into the dermis. And this gland is actually attached to some nerve endings. And so what happens is when this person, whoever's skin this is, when they get upset, these glands can be stimulated to pour sweat out onto the surface of the skin. And of course the sweat brings heat with it. So as the water molecules evaporate and separate from each other, they also release heat. And so this is why these types of glands go for temperature release. These glands are called sudoriferous. Sudoriferous glands secrete sudor, which is sweat. There are eccrine glands, which go for thermoregulation, and that's what I've drawn here. This is an eccrine gland. There are also merocrine glands, which their purpose is it's kind of up in the air a little bit sometimes. So there are nerve endings that attach to the sudoriferous glands. There are also just some nerve endings that just kind of end. And these nerve endings are usually the ones that take temperature. They might also sense pain. And these are called free nerve endings. I mean, I think the word free really means like they have this free ending to them. They're not attached to anything. But I also feel like they're free nerve endings because they're free to sense more than a few different things. I'm also going to draw genitalia. No, I'm sorry. I couldn't help myself. I'm also going to draw a hair follicle. And that's what this is right here. The hair actually sticks up outside superficially off of the skin. The follicle itself, and follicle is just a word that usually means a growth structure surrounded by cells, but the follicle itself is actually deep into the dermis. Now, coming off this follicle is a gland that kind of comes off it right here, and it looks like this cloud. And this gland here is called a sebaceous gland. sebum is what it secretes, which is basically an oil. And so as this hair grows, the sebaceous gland lubricates it. And we can draw a sebaceous gland over here as well if you would like. But the sebaceous gland actually secretes oil onto the growing hair. And as the hair pushes through the dermis, that sebum lubricates the growing hair. Now, again, hairs are also attached to free nerve endings, right? And this is why when temperature is sensed, and this is why hairs can also sense like a wave of air, right? They can sense a wind or a light breeze, a light touch. And so these sensory endings also do that. Now, hairs have a different structure to them as well because they are actually connected to the epidermal ridges. And in that connection, there's a little bit of smooth muscle. And so what this structure here is called it's called an erector pili, which means hair that is able to stand up. And basically, this is the smooth muscle of the erector pili. And I just want to point out that all of your erector pili stand up all at the same time. So all of these are controlled by nerves that are everywhere. The other structure that I've drawn here too is actually a dense regular tendon. So this is dense regular, not dense irregular, connective tissue. And because it's connected to a muscle, it's a tendon. Now most of our tendons connect our muscles to a bone, but this is different here. This tendon just basically anchors the erector pili to the epidermal ridges. There are some other sensory structures that can be found in the dermis. There are structures that look like this, and there are also structures that we did talk about a little bit. This structure over here, this is called a lamellar, which means sheet, corpuscle. Lamellar corpuscles are deep in the dermis, and lamellar corpuscles are capable of sensing pressure. So these are baroreceptors. Now, a lamellar corpuscle being very deep into the dermis, it is only capable of sensing a very heavy touch. This up here is called a Merkel cell, or a Merkel disc. And it's actually on the border of the epidermis and the dermis. And so it is also a baroreceptor, but it is only capable of sensing light touch. So the location makes a difference, right? If you're more superficial, you're able to sense a light touch. If you're deep, you're able to sense a very heavy touch. I also want to show you something that's very interesting about the hair. So as the epidermis approaches a hair, it dips down into the hair, covers the sebaceous glands, and then rises back up to continue on its way. And it's important to note this because this is not what it does with the sudoriferous gland, and this is not what it does with any of the other structures that span both the epidermis and the dermis. It's only these hair follicles that are actually lined by the epidermis itself. And so if I were to take a cut right here and look at it, right, if I were to take a cut and look at it from top down, I would see the hair, but I would also see the epidermal cells, the keratinocytes, surrounding it. Even though I've taken a cut that's in the dermis, I will still see that surrounding it. And I'm sorry, I should have put this, that was the epidermis, and that down here is all of the dermis. But I guess you kind of sense that throughout this. So these are what are called accessory organs of skin. Some people don't consider them full organs. Hair, yes. The glands, not everybody agrees on that.